Hello everyone. So in this second video, we're going to continue where we left in the last video. So in the last video, I talked about creating a new feature named length. So now we create a new feature named length to check the length of each message and convert every alphabet to lowercase in the message. So for that, we just have to let's, let's run this piece of code to check the values for length. Now I'll just restart and run all. And we'll wait till its output gets run. And now, so now you can see, now we will define again for converting every message to lowercase length. We have to define a new thing, new column name message df message .str or lower. I'll just print the headings. And then I'll run this. Now you can see the values. In the first column, you can see the length. It's printed out for each message. Now in the second column, along with the length, every character has been converted into lowercase. Now besides all these steps, now we have to do some common tasks that can be done on every NLP project. So we first will have to clean the data using regex, which is the matching patterns in the email messages, and replace them with some more organized counterparts. And then a cleaner data leads to more efficient model and higher accuracy. So we'll be using the steps such as for the pre-processing. So we will use various steps for pre-processing the messages. One will be the replacing the email addresses. Second, replacing the URLs. Third will be replacing currency symbols. And fourth will be replace 10 digits phone number. For even the format include parentheses, spaces, no spaces and dashes. And fifth, we will be replace numeric characters. Sixth, removing punctuation. Seventh, replace white space between terms with a single space. And eighth will be removing leading and trailing white space. And yeah, so these are all the steps that we'll be pursuing doing this. So now let us begin by replacing email addresses with email. So df message equals to df message .str replace, and we have to write the regular expression. So you might have seen this expression, power dot plus at the rate square bracket gain power slash dot gain dot star slash dot, and every character we want to know. So A to Z curly brace 2 comma. So we'll be dealing with the then we want $sign parenthesis. Now we will be replacing this with email address. Okay, wait, let me add even comment also so that we are able to understand at what step why we are doing and what we are doing. So this is the first step. Now next step is basically to replace URL with the web address. So again, let me just write the comment. Okay. So now in this step, we'll do again message equals df message. Okay. str dot place. Again, we'll make use some regular expressions. HTTP because it follows HTTP structure. A to C, capital A, even including digits. That's why. And then finally close the bracket. Okay. Now plus sign, move dot A to C, A to capital C, 2, 3. Okay, 2, 3, 3, closing parenthesis, circle bracket, but not this, as star, cash capital as star, closing, question mark, and top. We have to replace it with the web address, or if it finds anything like URL, so it will going to replace it with the short string web address. Now next step is to replace the currency symbol with anything like money as be something sort of you think. So let me just write a comment for it, just copy paste it. So this, for this, what we have to do again, df dot message equals to df str replace, and for currency we just have to write euro sign for euro sign, since it can be in dollars and euros. So for euro sign I have to just copy it. So just wait a second, let me just copy it. Let me just visit and explain the code. So for every euro or / dollar sign, it has to be replaced with dollar something sort of thing. The final step is to replace the 10-digit phone number. So we will even include the formats, including the parentheses, spaces, and no spaces. Let me just write a comment for it. Now, doing it for that, we have to just write message place at power sign question mark bracket d square bracket close curly parenthesis 3 parenthesis close question mark square s close question mark d close 3 we do this just 4 parentheses, and finally dollar symbol. Yeah, now this has to be replaced with phone number. And finally, we have to replace the numeric characters with, replace it with NUMBR. Simple. So for that again, message goes to df message str.replace r/t plus parenthesis dot question mark place with m. I will run this piece of code, center. Okay, now it has. Our next step is to remove punctuations. Now for this, we have to just type message df message str place r square bracket w d s, replace it with empty space. We are just putting like this. Now next step is to replace white space between terms with single space. For that again, message equals to df message str dot replace comma again with empty space. Now finally remove the leading, and training white space. df message df message str dot replace r plus question mark dollar and replace it with empty space. Yeah, we have to close the bracket itself. So we are good to go. I run this piece of code. Now the next step is we just see that all this changes has been reflected or not. For that, df.head. Now let's see, and you can see this number that we just used here for replacing the numeric chars has been shown here, white space, and it has been replaced with the number. And yeah, our entire process has been done correctly. So final step is basically to remove stopwords. So for stopwords removing, we have to first import a string because we will be dealing with the string module, then NLTK, and from NLTK corpus we need to import stopwords, and now I'll define stopwords. Set stop words and we have to specify that we are dealing with English. So English language, we have to specify plus square brackets. And there's a systematic words that you need to copy. So for that, let me just paste the piece of code. Okay, so after pasting this, we have to just remove this particular symbol. So we are just adding the English stop words along with UR, for UR. And finally, it will be apply. And are you using a lambda function? If you know how to use it, you can even use norm function, but I want to do it in the one line, that's why. If term not in run this piece of code. Okay, how this process has been done. Now what I'll do, I'll add a new column. Yes, length after remove. So for that, again, I'll define length GTH. df dot message dot str n. Finally, we print df dot head c. I'm going to run this piece of code. Now you can see has been reflected or not. Yeah, has been reflected. We do not have any stop words and no punctuations. Each and everything removed. Now, in order to see the total length removal, so total removal, what we can do, just we have to print original length. Just specify how to specify this df dot len gth dot sum. This will give length dot sum. So now cleaned len. In order to fetch the clean length, so you can just type in score again dot sum, because we want to add for each values. And finally, the total, that will be able to know that how many words have been removed. So for that, just dot length dot sum, and we have to subtract this from the df dot clean. Yeah, you guessed it right. You might have guessed it already. So you might have guessed it already. We have to do just like this. Okay. I'm find a piece of clothes. Let's see how many words has been removed. Okay. So original length was this 93,44743. After cleaning this, so these many words has been removed. These words included stop words and as well as punctuation. So these words do not add much meaning to our machine learning model. That's why we have removed it. Yeah. Now we'll even have a graphical visualization for counting the number of labels. So let's again type graphical for counting number of labels. So we have plt dot figure. We have to specify fixed size equal to, specify 6,4, and we'll make use of the Seaborn library. We are having a count plot, and we have to specify among which level we have to, for which columns we have to use Seaborn count plot. Just write label palette equals to rex plt.ti title counting the labels, font size equals 50 dot x text. We have to specify how many rotation. I will be using the rotation parameter to be horizontal, and finally, in order to make them appear on screen, show, we will print the tf dot label dot value underscore counts. Run this piece of code, you will see a beautiful graph. Okay, now you can see. So in our data set, 1 stands for spam emails and 0 stands for non-spam emails. So basically this graph shows the number of labels. Now we can even draw a visualization in order to depict the message distribution before cleaning. So for that, ax equal to plt dot subplot. Subplot are basically used for drawing more than one graphs. So fig size equals to, we'll be using 15,8, and again with the help of Seaborn, this plot, because we are plotting distribution curve, and we have to specify from which you have to plot. So df dot label double equals to 1. Okay, only selecting the values whose values is lying between. Now outside this, we have to specify length parameters. Now we have to specify the number of bins. So I'm using 20 bins. Ax equal to ax square bracket 0. Label should be spam message distribution, and ax 0 dot set x label should be spam message length. Now ax 0 dot legend. Now same we will do for the not spam task. We have to just copy the paste the code. So let me just copy paste the code, because in order to just type the same thing, it doesn't make sense. Now you can see after it then I have called the plt.show spammer, and we even haven't specified the color that I want for the red color R and for the blue color blue. And I run this piece of code. Okay, figure size 40 axis. Okay, I have wrote this 2 times. Okay. So now you can see this graph. It shows the distribution of messages. Now, since this video is getting a little bit longer, we'll continue with the third graph that we'll be plotting the message distribution after we have cleaned it. So we'll see in this next video. Okay, hope you like it. Bye.